today we are going to be looking at 3D. So with 3D, it's building on all of your understanding on 3A, B, and C, which is looking at dilation, looking at reflection, and translation all in one. So if you are still having issues with them separately, make sure you focus on those first three exercises first before going through this. I'm not teaching anything new, it's just putting everything together. I'm just going to do some examples. So we're going to start off with the equation y equals x squared, and we're going to apply different transformations to this function. So the first thing I'm going to think about is a dilation of factor of 3 from the x-axis. So because it says from the x-axis, it means I'm stretching away from that x-axis or I'm compressing. If I'm stretching, it's affecting the y value because it's a vertical stretch. So all I'm doing is what is my y value? Y is equal to x squared. So I'm putting my dilation factor in front of that x squared. The second part it shows is I've got translation of 1 unit in the negative direction. So that's where normally we would be having its brackets. I can find my screen. So right here, whoops, I didn't mean to cross it out with pen, but right there, I'm going to put that x into brackets. So that means to get it to move in the left direction, it's going to have x plus 1. Okay, so the next part that we will look at is going 2 units in the positive direction of the y-axis. So we know that when we move across the y-axis, it's at the very end with our turning point. So I'm just going to put plus 2 at the end. We're going to do the same transformations with y equals 1 over x cubed. So we're going to have a dilation of the vertical stretch, which means we're timesing 1 over x cubed by 3. So that means the 3 is going to be in the numerator. The next part is we are going to have that translation of negative 1 unit on the x-axis. So wherever my x is, I want it to shift over, so it'll be plus 1. And finally, I'm wanting to shift up by 2 units on my y-axis, so that will be the leftover part, plus 2. Again, make sure you're pausing the video, having a go yourself, so you're not just listening to me. We'll just do this last one. We've got y equals x squared, and it says a dilation of factor of 2 from the y-axis. So if it says from the y-axis, we're referring to that stretch as horizontally. So if it's a horizontal stretch, it means that x is being affected. Now, if you have forgotten, because it's got that factor of 2, we're just going to divide that x by 2. Now, also, let's remember that when we do this as well, we'll delete this in a minute, but if I just write down y equals x, so I've just written the equation there, and if I get the squared onto the other side, so that means I'm going to have x is equal to square root of y. Now, as soon as I've got that, the next part is, because that's what x is, I'll be putting 2 on the outside there. So this shows straight away that to get the everything back, I'll be dividing everything by 2, so I end up with x over 2. So it's just important to know where that comes from. So the next part is looking at the translation. So we are looking at translation of plus 4 on the x-axis. So that means we are going to move that x over by 4 units. So we need to think about where we place that, and it's just exactly where that x is. So to move it over in the positive will be x take away 4. The final step is that translation of 1 on the y-axis. Now, it says in the negative direction. So, first thing I'm going to do is at the very end, I'm just going to put take away 1. Let's have a go. This time we will sketch. So again, we've got sketch the image of y equals 1 over x under the following transformations. So the first part is a reflection in the x-axis. So if we're doing a reflection in the x-axis, if it's y, it'll become a negative y. So be mindful of that. So that means we already know what our y is, so we're just putting a negative in the front of 1 over x. The next part, it says a dilation factor of 3 from the x-axis. So again, if I'm thinking about from the x-axis, I'm talking about a vertical stretch. I'm stretching away. So if I'm stretching away from the x-axis, I am talking about timesing my y value by that dilation factor. So in that case, I've got 3, so I'm timesing it by 3. Finally, I look at the translation and it says 2 units in the negative direction on the x-axis. So that just means if I want it to go in the negative direction, I need to have with x plus 2. Finally, I've got translation on the y-axis in the positive direction of 3. So at the very end, I am just adding 3. Now, if I wanted to draw this, we already know we're going to have 2 asymptotes. One will be looking at my denominator, and the other one is going to be looking, I'll get a pointer, is going to be looking at the plus 3 here. So that means when y equals 3, that will be an asymptote. And also when x is equal to negative 2, because I can't have this equal to 0, it will have an asymptote. Because of its reflection, it also means that we will be looking at quadrant 2 and quadrant 4, even though it goes, I'm just talking about those 4 quadrants, even though it's not on looking at the axes. So I'll show you it here. I was meaning quadrant 2 and quadrant 4 is the major areas. Let's have a go with one more. So we've got y equals x to the power of 3. And this will be the last one we do. And it's going to go under some transformation. So it says a reflection in the y-axis. So again, if we are talking about a reflection in the y-axis, the x value has to change, which means if it's positive, it's going to turn into a negative. So if we're doing that, wherever x is, we're just putting a negative. But I want it to be for that x, which is why we have brackets. Then it's got translation of 3 units on the x-axis in the positive direction. So that means wherever the x is, it's going to be shifting and it needs to be in the positive direction, which means it's going to be take away. So be mindful of that other negative. So I wrote it like this because it's the x value that is being changed regardless of this negative here. Then I'm going to simplify this further and apply that negative on the outside. The final step here, I've got translation negative 2 on the y-axis. That just means on the outside, I'll have takeaway 2. I've tried to color code this so you can see each step clearly. Then we've got a dilation of factor 2 from the y-axis. So when it says from the y-axis, we're stretching away from it. So it's a horizontal stretch. A horizontal stretch meaning it's affecting the x value. We talked about how when we do dilation, it's going to be that x value divided by 2, which is what I've just done here. I forgot to color code this part, and I've just put the graph there. Again, if you are stuck on the graph, on how to graph, I would highly encourage you to go back to the videos from year 11.